Hi there, Mr. Sutton here, bringing you the IM3 Chapter 2 Quiz 2 Review Solutions on Advanced Factoring. For this problem, we're faced with a trinomial that we have to factor that has an a value, a squared coefficient, that is not 1. So in situations like this, the very first thing we should do is to check for common factors. So can I take anything out of all three terms? Well, it looks like 2 is divisible into 2, 6, and 108. So that'll be my first step, is to factor out a 2. And that leaves me with k squared minus 3k minus, this will be 54. Once you've taken out a common factor, you should always check to see if whatever's inside the parentheses can be factored further. Now inside, we have a trinomial with an a value of 1. This is really 1k squared in here. So I can just ask, what are factors of negative 54 that add up to negative 3? Well, let's see here. We have 1 and 54. That's not going to work. 2 and 27 doesn't work. Let's see. Does 3 go into 54? It does. That would be 3 and 18. That's not going to work. 4 doesn't work. How about 6? 6 and 9. Yeah, that would work if I had positive 6 and negative 9. So I can rewrite this then as 2 parentheses k plus 6, k minus 9. And now this is completely factored. For this problem, we're factoring a trinomial where the a value does not equal 1. So as always, we check to see if there's any common factors we can take out. And there aren't. 7 doesn't go into 19 or 10. And there's also no perfect square kind of shortcuts. This is not a perfect square trinomial or any of those other special factors. So at this point, when there's nothing else, we use either guess and check or the AC method. I'm going to go over the AC method here. I mean, guess and check, you're basically just guessing things that it could be, like 7n and n for factors of 7n squared, and maybe like 2 and 5 for factors of 10, and then multiplying it out to see if you get that middle number of negative 19n. So that's not what I'm going to show you here. We're going to review the AC method. To do this, you multiply the a and the c value together. So 7 times 10, that's going to give us 70. And now we're looking for factors of AC, factors of 70, that add up to this middle coefficient of negative 19. We know the numbers are both going to be negatives because they multiply to give us a positive and add up to a negative. So let's take a look at some possibilities. We've got 1 and 70. That's not going to work. 2 and 35 is not going to work. Let's see here. 5 and 14. That'll work if I have negative 5 and negative 14. Once you've found the numbers, you're going to split up that middle term into those numbers with each with their own variable. So this becomes minus 5n minus 14n instead of 19n. And now once you've got 4 terms, you can factor this by grouping. To review how to do that, you take a look at the first 2 terms and take out a common factor from that. So n can get factored out of those 2. That'll leave us with 7n minus 5. And then you also take a common factor out of the last 2 terms. So between negative 14n and 10, the common factor is negative 2. That will leave us with 7n minus 5 inside. You should have the same thing in both parentheses because you're going to take out that parentheses, 7n minus 5, as a common factor. And then whatever's left over, the n minus 2, that goes in a parentheses next to it. And now this is fully factored. For this problem, since we have an a value that's not 1, and taking out common factors doesn't work, and these are not both perfect squares, I mean 4n squared is a perfect square, but 5 isn't, we're going to use the AC method to factor this. It's kind of the last resort. So we've got our a times c, 4 times 5, giving us 20. And now we're looking for factors of that AC value of 20 that add up to 12, that middle value, that middle coefficient. So that would be 2 and 10. 2 times 10 is 20. 2 plus 10 is 12. So we split that middle term up into 2n plus 10n. And now that we have 4 terms, we go ahead and factor by grouping. So for the first 2 terms, we can take out a 2n, leaving us with 2n plus 1. For the next 2 terms, we can take out a 5, leaving us with 2n plus 1 there as well. And now we factor out that 2n plus 1 repeat parentheses as a common factor. And whatever's left over, the 2n and the plus 5 in this case, those go in the parentheses next to it. On this problem, we're multiplying conjugates together. That's factors that have the same terms, but one with a plus and one with a minus. So in situations like this, where you basically have a plus b and a minus b getting multiplied together, your answer is going to be in the format a squared minus b squared. So that's the form we're going to be trying to put our answer in. Now to do this, to get a squared, you just have to take the first thing, 3x in this case, and square that. So that'll give us 9x squared. And to get b squared, you just have to take the second thing in each parentheses, 7 in this case, and square that to get 49. And you'll always have a minus in the middle, because you're always multiplying opposite terms there. So that's minus 49. In order to square a binomial, the long way to do it would be to rewrite this as 8x plus 5 times 8x plus 5, write it twice, and FOIL it out. The shortcut, if you have an a plus b squared sort of situation, involves using this form here, a squared plus 2ab plus b squared. So to use this shortcut, you square the first thing, so 8x squared. That'll be 64x squared. And then to get this middle 2ab term, you have to multiply these numbers together and double it. So 8x times 5 is 40x. Doubling that gives us a plus 80x. And then for b squared, you just square that second number. So that would be plus 25. For this problem, we notice that we have a difference of two perfect squares, and we can't take out any common factors. So if you have an a squared minus b squared situation, you can factor that into the form a plus b, a minus b. For a and b, you just have to square root the two things they gave us. So the square root of 64r squared is going to give us 8r, that's our a value. And for the b value, we square root 81, that's going to be 9. So we're going to have 8r plus 9, and then same thing with the opposite sign, so 8r minus 9. To factor this problem, as always, we look to see if we can take out common factors in the beginning, especially if I have an a value that's not 1. And I notice here that these both divisible by 3, so let me factor a 3 out of all that. So that leaves me with n squared minus, let's see, that'll be 16. And now I notice that I have a difference of squares, a squared minus b squared. So the form for that factorization is a plus b, a minus b. So to get that, I have to take the square root of n squared and also 16. So let me bring down that 3 so I don't forget to do it later on. And now square root of n squared is just n. Square root of 16 is 4, so we have n plus 4, and then n minus 4. On this factoring problem, we have an a value, a squared coefficient that's not 1. So we first look to see if there's common factors. There are some between 16 and 72, but 81 throws everything off, because the only factors of 81, well, they're 3's basically, and no 3's go into 16. So that means we have to look for shortcuts maybe. 16v squared is a perfect square, so is 81. So we do have a perfect square sandwich, which means we might be able to use our perfect square trinomial shortcut. So if this is in the form a squared plus 2ab plus b squared, then the factorization for this would be a plus b quantity squared. The million-dollar question is this 72v really a 2ab, or is it something else? So in order to see, we have to actually put things in this form and then test it out to see if it works. So to get a, we square root the first perfect square. Square root of 16v squared would be 4v. For b, we have to square root the last perfect square, 81. That square root is 9, and it's going to be plus 9 because this middle term is positive. We use the sign of that middle term to figure out if this is a plus or minus in here. So 4v plus 9, and that whole parentheses is squared. Now we're not done, because we have to test to see if we actually get 72 when we multiply this all out. A quick way of getting the relevant part of this is just to multiply these terms together and double it to get the middle term we would get if we multiplied everything out. So if we do 2 times 4v times 9, that's going to be 8v times 9, which is 72v. Since that matches what we have up here, that means this is actually the answer. And just a quick note that this check doesn't need to be shown, but you do need to at least do it in your head to make sure things work out. On this problem, we have an a value out front that's not 1. So let's start by trying to take out a common factor. It looks like all of these are divisible by 5. So if I take out a 5, that leaves me with v squared minus 8v plus 16. And now inside here, a lot of ways you could factor this. If you want to get fancy, you could use your perfect square trinomial shortcut. This is a perfect square sandwich, so we could try putting this into a minus b squared form. Let's give it a shot. So let me bring down the 5 just in case this actually works. And now to get a, I have to take the square root of v squared, which is just v. To get b, that's the square root of 16 in this case, so that's going to be 4. And it's going to be a minus 4 because this middle term here is negative. And now let me just multiply that back out and make sure it works. If I multiply v and negative 4 together and double that, so 2 times v times negative 4, that ends up being negative 8v. Since that matches what I had in the middle before I did that factorization shortcut, that means this is actually the answer. Now, if I got something different when I tested this out, I'd have to go back to the drawing board and try a different factoring technique. But since it matched, I can call this problem done.